Hey everybody, this is Kai Werner from Confluent. Welcome to the session about manufacturing for Industry 4.0 with Apache Kafka and event streaming. This session focuses on use cases. I will give examples from automotive, semiconductors and other industries and really just talk about architectures and about what you can do with event streaming and what we see from our customers. So it's not deep technical stuff, but really focusing on what you can do. And therefore, here's the agenda for the next 60 minutes or so. First, I will talk a little bit about Industry 4.0 and the digital transformation in the industrial IoT. And then I will give a quick 10,000 feet view on event streaming and Kafka for Industry 4.0. And afterwards, I will really tackle several different use cases because we see Kafka used in so many different scenarios, and this is still just some of them. But this gives you a great overview about different kind of architectures and deployments. Let's begin with a perspective on Industry 4.0 and how event streaming changes that. I mean, this is really like on every marketing slide. Industrial IoT is about modernizing how you produce things. That's how it is, and therefore you use more sensors, more automation, robots, and so on. So it's simply a complete change in how you produce things. The digitalization changes the whole manufacturing process. So this is also part of the reason why I can show you so many different use cases today. So it influences R&D, but also procurement, and then also the manufacturing and supply chain. But it's really not just about the part of the producing, but about the overall process, which is completely changing and getting more digitalized, as you can see on this great screen from McKinsey. From Kafka perspective, people typically come from the software and IT side of the world. And therefore, it's really important to understand that the automation industry, which is the OT side, is very different typically. So here you build machines and production lines which run for 20, 30, 40 years, as you can see on this picture. And in addition to that, it's typically proprietary and monolithic. So you cannot change things quickly and scale up easily. And it's not open interfaces. It's really proprietary and complex code. And security is not really a thing there. At least it wasn't until now, because you didn't need it. You had it in the factory, and it was there without any kind of internet or network connection. And of course, there's no changes with the digitalization to implement these use cases we will see today. So in the end, it's an evolution of IT and OT convergence. As you can see here on the one side, you have the machines and sensors and field bus and so on. That's the OT part. And then you have the traditional IT stuff, which is now going more to the cloud, but often it's still in a data center or even in the factory today with the Industry 4.0 movement. And so it's converging more and more. And this is also why we see so much demand for Kafka and event streaming all over the place. As you can imagine with this, there's a huge demand for an open, flexible and scalable platform, because that's not what the industry and in the automation industry was in the last 20, 30, 40 years. And so this is changing, and with this, the whole thinking is changing how you implement your use cases. And with this, we now need to change the whole infrastructure and the architectures. And therefore, that's why we come to event streaming for Industry 4.0. So let's take a look at that from 10,000 feet. Event streaming means that you continuously process data and analyze it in flight while it's in motion. That's a very different approach from storing everything in a database first and then later consuming it from a web service or a SQL query. And this is the key difference. You want to continuously process the data and also aggregate data from different systems. Not all of them are real-time. Some are coming from database pushes, some are coming from files. But in the end, you correlate the data as fast as possible without first storing it somewhere else. Because otherwise it's too late. So you cannot do predictive maintenance if you find out that a machine is already broken. Just to give one example. And this is where Kafka comes into play. I will not give an intro into Kafka in detail here today. There is a lot of other sources. But really on one slide, Kafka is a game changer because it's an event-based streaming platform. This means you can continuously process data in real time at scale for gigabytes per second. But on the other side, it's also a storage system and not just messaging. So this means that these events are also stored in Kafka as long as you want. And this can be a day for log data, or this can be a year or forever for business transactions, like if you integrate with your ERP system or MES system. And Kafka also provides integration capabilities to both sensors and real-time systems, but also to databases and analytics tools. But it also, with the storage part, it decouples all these systems. A producer always produces data. It doesn't ask if the consumers are ready to consume it. And so this is really the significant difference of Kafka compared to other messaging and database systems in one single slide. Of course, we could explain in more detail, and I have other material about that. Another important part about Industry 4.0 is that it's typically hybrid, because when you produce tangible things, it's in a factory, it's at the edge. And on the other side, you also have software which is either running in a data center or often cloud first, where you run it on Google or Amazon or maybe on Alibaba in China. And therefore, it's really key that you can deploy these use cases in a hybrid architecture. And that's where Kafka is so strong, because you are very flexible depending on your needs. There's plenty of different architectures. So there can be a digital service at the edge where you deploy Kafka in the factory, for example, to directly integrate with the sensors or with a local MES system. And on the other side, you can also replicate the data to the cloud, so that you then in the next step maybe have aggregation scenarios where you have one Kafka cluster in the cloud and you integrate in both directions with different factories. And these factories can either also run Kafka at the edge, or they have another proprietary system. That's also totally fine, but you can still aggregate all these different systems, or at least an aggregated and pre-processed version of these systems, to build another digital service in the cloud or connect to other third-party services in the cloud. And then with that in mind, of course, in Industry 4.0, it's often global, or not just about one factory, right? And therefore, with Kafka, the great thing is that you have different options of how to deploy your infrastructure. This can be a scaled disaster recovery deployment, where you run one Kafka cluster stretched across different regions. For example, one single Kafka cluster over US West, Central, and East. Or you have aggregation scenarios, like in yellow here, where you have small factories and they all replicate some of the data to a cloud infrastructure in the same continent, where you do the further processing or analytics. And then, of course, you also have replication between clusters in different continents. And here you replicate data in real time between them. And with these kind of architectures, in addition to Kafka, Confluent has a lot of great tools for that, like multi-region clusters and cluster linking. So there's many different options depending on your requirements. One example of such a really big deployment of Kafka is Tesla. So they talked at a former Kafka summit and also blogged at the Confluent blog about how they process trillions of messages per day for IoT use cases with Kafka. And they have the usual problems there, like it's bursty data and they need it in low latency and the payload is exploding. And they also need to process it in real time. And so they started with RabbitMQ, like many did many years ago, because they thought it's all about just messaging and processing the data in real time. But actually, it's more than just sending data from A to B in real time. But you also need to integrate with systems. That's why they moved to Kafka for higher scale. And also, for example, as you can see here in 2017, they started also using Kafka Connect for data integration. And now they process trillions of messages per day. And for them, it simply works because it can scale up, it can scale down. In their Kafka Summit talk, they also mentioned how they have deployments at the edge where they do some kind of pre-processing, because you don't want to replicate all the data to the cloud. That's not really cost efficient. And also for latency reasons, some of the processing has to happen in the factories or when you do it at your energy deployments. But also, because it's real-time, it can still do integration with other systems, like with batch systems or with analytics tools. So this was the general 10,000-foot overview about event streaming and Industry 4.0. Let's now take a look at several different use cases. In this talk, I will only go on that on a high level, because otherwise I would speak for 10 hours probably, but I hope this gives you a good overview. And therefore, we are starting with the track and trace and production control and plant logistics kind of use cases. And here it's really about traceability, and you want to get control about the whole system. And this can be either just the plant logistics, or this can be really a more global deployment, so across the different factories, for example, or also when you're working with third-party providers. And you want to get transparency about your inventory in real time and these kind of use cases. And one really critical characteristic here to point out is that Kafka really decouples the different infrastructures and systems, both on the OT side and on the IT side. And the reason for this is that Kafka uses storage under the hood, as I mentioned. So it's not just a point-to-point messaging system, it really decouples systems from each other. And like on the bottom left side, where you might produce data continuously with MQTT sensors, and in the OT domain with the SAP integration, this SAP system might not be built for that because the ERP system is still built on web service and a relational database, so it doesn't scale well for MQTT. So with Kafka, you have the decoupling between them and the back pressure. And probably you also use another event streaming application which pre-processes and aggregates the data so that you don't overscale the SAP system so that it crashes. But in parallel to that, another analytics domain, which might be deployed much later, can consume all this data from the IoT systems in real time to do predictions, maybe for a Java or a Python app. And this is really key for the success of Kafka and why people are using it. It decouples the different systems. Some are modern and scalable technologies, and some others are legacy and monolithic. And then, of course, it's not just about processing the data at the edge, like in a factory, but really about data correlation across different regions. A great example for this is how Lyft does it. This is not really manufacturing, but this is still IoT related, but a great public example. How Lyft does map matching. This means they correlate data from different systems, like the GPS of the mobile phone, but also other systems like the Wi-Fi hotspots, so that they can really know where the customer is because GPS is not good enough. And 5G will make this better, but this is the situation today. And this is the same what you need in manufacturing, where you need to use different information to correlate the information to make the right choices and decisions in real time at scale, 24/7. That's what Lyft does, and that's the same what Uber does and other ride-sharing do. But also that's the same what we see in factories where manufacturing companies use these kind of things for correlating the data from different data sources in real time to make the right decisions on, for example, the plant logistics. So here's one example for that from Bosch Power Tools. So Bosch is a supplier and a very big global supplier, and Bosch Power Tools is just one division of them using Kafka like many others. And one of their projects is about track and trace. So they're doing construction site management. This means the construction machines and devices are produced in the factory, but then they are shipped to the construction areas where people use them. And they needed a track and trace application because they always need to know where the machines and devices are exactly. They had trouble spotting them in the past. And also they use it for sensor analytics to find out if you, for example, have to recharge a machine or replace some parts of that. And also you have mobile apps from the management perspective, which can take a look at all the different construction areas and make decisions based on that. So this is a very nice example for a track and trace application with Kafka. This is an example, by the way, not for big data. So this is actually smaller data sets. Here really one of the key features for Kafka is that it's on the one side using data integration capabilities, and also on the other side to having this kind of decoupling again, where you on the one side have sensor data, but also on the other side, for example, HTTP requests from the mobile app. Another great example is Bader. Bader is a food production company, and they have built their complete food value chain in an IoT-based and data-driven manner. This means they have a single source of truth across the food value chain. And this is not just about one factory, but really across the region, so that they can monitor the business critical operations. And they do things like tracking and calculations and alerts. All of that at scale in real time by connecting to several different internal systems, but also to external systems, as you can see on the left side, like GPS information and weather information. And also on the right side, you see, this is not just Kafka. Of course, Kafka is not the silver bullet for everything, but it's the real-time central and scalable infrastructure. And from that, you can also, for example, connect to other databases or analytics tools, like you see here with Elastic and Mongo and S3. So in addition to track and trace, you can also do more powerful scenarios like location analytics and geofencing. This is really a great example in the factory where you have these kind of robots or cobots which are moving around, and you want to make sure that they only move in a specific space. And to guarantee that, you implement geofencing. and this obviously has to work in real time at scale, and it also has to correlate data from other systems, or not just from the robots, for example. And here is a great use case where this is implemented with KSQL. With KSQL, you can do that to write just SQL queries, but continuously process this data and also connect data from different systems and correlate it. And based on that, you can control the robots or other machines, and you have location-aware information in real time for doing triggering of events and alerts. The next use case, or kind of use cases, is quality assurance and yield management and predictive maintenance. Of course, one of the key buzzwords we hear all the time in Industry 4.0. So here it's all about improving the overall equipment effectiveness. So there's a few different metrics you can use, like the OEE. But the point is really you want to make the manufacturing productivity better and reduce the cost. And there is different kind of architectures which you can use to improve the OEE in the factory and for the production line. Here's an example of an architecture where we really use Kafka as a data historian. So you know data historians, right? They are typically proprietary and monolithic. Many of them don't scale well. And more people use Kafka to build a modern data historian. It's open, it's scalable, it's flexible. And you can still combine it with other technologies, like you can see here. And at the bottom, you see that either you directly connect to data sources like syslog or files or MQTT, or maybe use another IoT gateway in the middle, like a Siemens MindSphere deployment, where you connect directly to Siemens S7 PLCs, for example. So that's up to you, and you're very open and flexible and even can combine these kind of things. And then you can use stream processing with technologies like Kafka Streams or KSQLDB to do stateless and stateful processing at the edge within the data historian. But then, of course, you can also then replicate data to the cloud, as we have seen before in the architectures, to do further analytics there, or aggregate data from different data historians from different factories. The point is really this is an open and scalable and flexible architecture where you can complement your existing legacy and monolithic architecture, but also build new, more scalable technologies. And here's one specific example. This is about early part scrapping to reduce the cost of the production line. And in this case, we have different stations, and this is of course a Hello World picture, right, with station 1 and station 2. And you have cost of $100 per item for each piece at before station 1, and then the station 1 costs you $200, and the station 2 costs you $150 again. And sometimes you have to even redo it at our station, which costs money again. And the earlier you scrap parts, the more money you can save. So this analytics in real time can help you to save money. And even if you reduce this by just 1%, often you can save millions of dollars over a year. And here's a specific example how customers implement this with event streaming. So this is an example from machine vision for quality assurance and yield management. And here, that's a very common example of applying machine learning to Apache Kafka. Of course, it can also be just some business rules written in Java or in C or C++. Or you can even use analytic models. For example, in this case, we are not directly connecting to the sensor data to the real-time aggregations, but we also integrate with cameras, which do images from the products from the assembly lines. And with this then we can use deep learning in a real-time Kafka applications to predict with our analytic model if we should scrap the part now or if we should redo it or move it to the next station. And this is all happening in real time at scale 24/7. But in addition to that, with all these live operations, we of course also ingest the data into another tool like a data lake where we can do further analytics to improve the model we use in the production line. The great advantage here is that we build one single infrastructure for both the real-time analytics at scale, but also for ingesting the data and using it in other analytics tools. And no matter if this is just in a factory or a complementary solution where you use it in a hybrid way, where you do the model scoring in the factory, but the model training in the cloud, for example. The next example is supply chain management, also, of course, very important in manufacturing. And it's really more or less an overlay over different sections. And here it's all about planning and coordination and not just about the technology, but of course also the processes and the people. And this is really a cross-cutting concern. And here, the more you automate and the more you can make it robust and flexible, the more successful you are. Typically, bigger companies use concepts like Six Sigma, but no matter what you use, typically people want to get more and more agile with that. So there's also Lean Six Sigma, for example, for this. The problem with supply chain management, it's a very generic term, so always define what you mean with that. Because it's typically a sewer of technologies and products, and we see customers buying some parts of that and they're building some parts of that by themselves. So you can mix that like you want, but in this picture you see that typically, even if you talk about an ERP system, it can be so many different things, and every ERP system is different, and under the hood it's typically a combination of different components, and sometimes the MES system or the BI system is part of the ERP, sometimes it's a different product. And so really you need just to define what part you're talking about. And this is now where we also come to event streaming with Kafka. And I really like this term of a postmodern ERP, which was coined by Gartner. And actually what they're talking about is replacing the legacy, monolithic and highly customized ERP suites, which are very complex and not cost efficient and also not flexible. You cannot easily build new things. And instead they recommend to build a mixture of loosely coupled, exchangeable applications, no matter if they're at the edge in the factory or if they're running in the cloud, whatever makes more sense. But in this way now you can combine the different parts of the postmodern ERP. And as you can see here, so this can be on the left side some specific proprietary systems built specifically for a use case, and it's totally fine if they are monolithic in some cases. But then on the other side, we also need to integrate with other systems. And one might be a modern SAP S/4HANA, which might be even in the cloud version, where you use it for the MES features. Or it might be an external tool like Salesforce for the CRM management. Or it might be another Kafka native technology. We see more and more vendors of IoT solutions and industrial IoT products used based on Kafka. And so a postmodern ERP combines the different technologies, and at the heart of that, no surprise, often the central technology in between is Kafka, because this is then the kind of core ERP or core integration layer. And if this is scalable at real time and 24/7 available, then you can easily integrate other systems with that. Some of them are also real-time and scalable, maybe even also based on Kafka. And some others are legacy with web services or using a database under the hood. That's totally fine. They can all be complemented. Because Kafka is, again, also the back pressure and an integration tool, not just to real-time systems, but also to other things like HTTP or a database or even a mainframe. And then in supply chain management, there is, of course, many different kind of processes. So let's take a look at a few of them and where Kafka can help, specifically for the use case now, not just the ERP technology in general. And one of them is supply chain planning, where you often want to know what if, right? What should I do next? And prepare for the unknown and the unknowable, and then act at the right time in the right context. So this is really a hard problem if you don't have a scalable, flexible architecture for that. And here's an example which ThoughtWorks talked about at one of the former Kafka summits, where they went from a batch-oriented system architecture to a streaming microservice platform. And this is really a great example for supply chain planning, because you have the different events, which are the shipment is created, or the plant demand is adjusted, or the schedule is generated, and many, many more. And this doesn't really work if it's all a monolithic and not scalable batch architecture. And therefore you have to decouple it. And sometimes you build new applications for parts of that. And for some, it's still okay if they're a web service, if you do a call once every 60 seconds. But if you have continuous events, then it needs to be an event-based application. And here also, what ThoughtWorks presented is a very common pattern we see everywhere, actually in any kind of Kafka deployment where you also have integrate with legacy. Typically, this is not a big bang, but you can replace all parts step by step. So you can easily combine batch applications and keep them running, but add new real-time applications to that. Like you see here, where some of the applications are still batch, but some others are deployed in real time. Because Kafka decouples them anyway, you can build new microservices in real time, but still connect them to batch layers, like as you can see here at the top, where, for example, you have a legacy database integrated with Kafka Connect. Another part of supply chain is supply chain purchasing. And I mean, we could talk now about every single part of supply chain and how you can use Kafka in the part. So in this case, I want to talk about a very innovative, modern, cutting-edge use case about using natural language processing for digital contract intelligence. And here's a great example for that. This is what the BMW Group has built. They have built an industry-ready NLP service framework based on Kafka. And by the way, the digital contract intelligence is just one of many use cases where they use natural language processing together with Kafka. And at their Kafka Summit talk, you can learn much more about their use cases. They use Kafka under the hood, as you can see on the right side, because it's fast and flexible, and it provides the right abstractions to build what they did. Because reality is, and this is not just for natural language processing, but in general for machine learning, and more in general for many other kind of use cases. You want to be decoupled and flexible and abstract. And in this example, BMW uses many different machine learning services for NLP. Some are more Java-based, some are more Python-based with many different frameworks, and some are even using cloud-native services from Azure or AWS. And so Kafka is used under the hood as a service framework using an event streaming engine so that you can do all this orchestration and integration with Kafka in real time at scale. No matter if one of these NLP interfaces is Batch or it's Python or Java, that doesn't matter. And in addition to all of these NLP services with machine learning, on the bottom right you can see they also ingest all the data into Elasticsearch, where they use a Kibana UI for doing other kind of monitoring and UIs. And this is one of these great examples where one Kafka pipeline can be used for different kind of topics. And even ingesting it into batch for analytics is fine, but if another consumer wants to consume it in real time, you can just attach it and get the data in real time. Or if you want to use the next generation, for example, AutoML, data robot for machine learning, then you can just add it here. It's totally fine, and still the existing services can continue to run, completely decoupled. Supply chain operations often is used for using the SCORE model. So here you see you have to do many things, right? It's cross-cutting, and you have to plan and source, make, deliver, return, return, return. So it's a big complex process with many third parties using that. And this is typically not even just for their own company or their own divisions. But in the reality, you also have to work with other companies and partners. Like if you are a tier 1 supplier for automotive and car makers, then on the one side, of course, you have to work also with the OEM, but also with the tier 2 suppliers. And therefore, the trend we see here is that even this kind of integration between different partners is using event streaming with Kafka. Think about that. More and more of these tier 1, tier 2 and OEMs use Kafka under the hood for the reasons we have explained about higher scalability, decoupling, back pressure, data integration, and so on. But then for the integration to the partner, today the best pattern used mostly is using an API with REST or SOAP web services. And this is somewhat ridiculous, isn't it? Because you introduce scalable solutions everywhere, and then your interface to the partner is a web service which doesn't scale well, and you cannot continuously process data. And then the same is true for the software vendors. Like if you use a third-party MES or ERP system, if you want to continuously do real-time demand planning and inventory management, that doesn't work if it doesn't scale. And therefore, people use more and more Kafka even for the integration between partners. And there's plenty of tools supporting you here, even open source Mirror Maker in Kafka, or tools from Confluent, where the most advanced and innovative one is cluster linking, where you don't even need tools like Mirror Maker or Confluent Replicate anymore, but you use the Kafka native protocol instead. And you can even use that for hybrid architectures, where you have Kafka in the cloud and in the factory. So this is really an innovative kind of architecture for Kafka, which you should think about. And last but not least, I thought for supply chain management, this is actually one of the really, really valid use cases where we see blockchains used. I'm not convinced that blockchain is replacing everything and used everywhere. That's what's being said for 10 plus years. But supply chain, especially with third party, is where it's one valuable use case. So here you can really evaluate blockchains like Hyperledger or Ethereum if you work together with other partners. But still they only work for specific use cases, and they are not really scalable. And so you should really think about where blockchain makes sense and the complexity is worth it, or if Kafka is good enough. Because also there's options, for example, for a tamper-proof Kafka. And in many cases then, you often combine Kafka with another blockchain. I have done a webinar about this. You can see the link here or just Google for it, because this is really important also to understand how these complement each other. Typically, it's not a question of Kafka or blockchain, but they are often combined. But my rule of thumb is really evaluate Kafka first and only use a blockchain if it's really needed. And the only use case where I really see it needed is if you work together with third parties on one specific use case. And even then, often it's not really needed because blockchain makes it much more complex. The next section, we'll talk about cybersecurity, and obviously this is a very hot topic everywhere. And in industrial IoT and in the Industry 4.0, we see more like this, like these are the famous examples like WannaCry and like NotPetya, where there were really attacks which worked well, because typically in manufacturing you used Windows servers without any kind of upgrades or updates for security and all these kind of things. And honestly, most of these issues do not even get into the public. So we know there's much more, and therefore only a few of them talk about their issues in the public, like Norsk Hydro with their ransomware attack. So this is a big problem, and you have to get security around that. And this is really important part for every Industry 4.0 deployment. So the threat about cybersecurity is real. And think about that, because with Industry 4.0, you need networking and communication, connectivity, open standards, and your factory has to be always on. Otherwise, you will not get the advantages of all the use cases I show you in this talk. But the challenges are then, of course, the attackers are also coming there, and it's different kind of attacks, like bringing the production line down. Sometimes it's more about ransomware, where you want to cache money. And the most important part here, typically, it's even a supply chain attack, where you attack the weakest partner. Like you don't even need to attack your security, but maybe the one of your small third-party vendors, which is also integrated into your system. And with that, then you can get into your system too. And the problem here is that there is legacy security technologies available, but they also were not built for the scale you need in Industry 4.0. They're not scalable to process all the sensor information in real time 24/7. And therefore, they simply do not work well anymore. And so this is why we see so much demand for Kafka, also for cybersecurity use cases, both at the edge in the factory and also in cloud deployments for more the business applications. And here is how that can look like, where you build a modernized security information and event management system, short SIEM, with Confluent or Kafka and the ecosystem. And often it's not just built with Kafka, but it's complementary to other solutions. Like you get all the data from the left and process and integrate that in real time at scale. And then the pre-processed data is ingested into something like Splunk, where you can do your analytics. On the other side, sometimes you even have to use this option, because some other more legacy kind of SIEM solutions, they don't scale well. So here you're forced to do the pre-processing and some analytics with Confluent or Kafka. For other use cases where they scale well, like Splunk, there often it's for cost reasons, because you can save millions of dollars in big deployments if you first pre-process it with Kafka and then ingest it into Splunk as an aggregated version. And in addition to that, you can also, of course, also ingest everything into a forensic archive if you want to analyze the data maybe a year later if you had a problem with that. But really, the threat about that is real. And sometimes it's just coming from wrong behavior from your employees, where you have one email login, which you use both for your on-site integration and login, but also for third-party forums or discussion and mailing lists. And this is an easy way to get in for cybersecurity. And so the important part here, this kind of cybersecurity has to act in real time to detect anomalies. So, for example, if one of your employees is logging in from a completely different location with a different IP address, if you have just a batch process and find this out a day too late, that's not working. You have to do this in real time at scale. Another part of where we see using Kafka deployed a lot is really part of this hybrid cyber data platform. Because, as I said before, and you might know that, so most of the factories only use Windows and proprietary protocols and deployments in the factory. And often even without security updates and so on. And so for this reason, you don't connect that to the internet. And that's one reason why typically we see this kind of DMZ in the factory where people deploy Kafka as this kind of cybersecurity interface between the factories, where often still one of the old Windows XP instances runs without security. But then you have the real-time cybersecurity on Kafka in the middle, so that even if there are anomalies, that they are blocked, in this case at Confluent at the edge, before you can even get into the Windows system if you're not the right user or something like that. And this is also often a solution because people struggle using Linux at the edge in factories. So you do not have to change all your Windows systems, but you can put a cybersecurity platform on Linux with Confluent in the so-called DM set in the factory, for example. The next scenario is about servitization. This in the end means digital twins, but the point is really that you build more and more digital services around your product. And I really love this picture from McKinsey, where they talk about how the business for manufacturers is changing, so that it's not just about the machinery anymore and about what you produce and sell. It's much, much more about the software and services on top of that. So even for machines and cars, we are getting much more into this subscription model, which you might already know from software vendors, but now we are also seeing this in industrial IoT and manufacturing. And only this is the future, because this is where you make the real money. It's not producing and selling, but it's about the digital services. And the digital twin typically plays a key part in this role. So you're merging the physical and the digital world. And of course, this is also for other use cases, like a digital twin is used for downtime reduction and inventory management. But this case here is now about servitization and customer experience, where you simply sell as a service. Rolls-Royce is doing that for many years already, by the way. So there you can buy your car by hour or by usage of kilometers or miles. So a living model really is driving the outcomes here. And that's in the end what a digital twin means and what servitization means. And this trend is clear in manufacturing. And therefore, actually, often also it's not the term about digital twin, but more about a digital thread. So it spans the entire life cycle, from the first parts of design and production until selling, and then until recycling at the end. So no matter if you call it digital twin or digital thread, this is really important. And as important is that we see more and more usage of Kafka as part of digital twins. The reasons are very similar as discussed before. It's scalable, it's open, it's flexible, and you can build your digital twin like you want to do that. So in this case, we use Kafka as IoT platform to integrate to the sensor information and to other real-time applications and to other batch systems. And one of the external systems is the digital twin, which you build outside of Kafka with another tool, or maybe it's a commercial proprietary product you buy. And on the other side, we even see people building a real digital twin based on Kafka. The huge advantage here is that Kafka under the hood is still event-based, so you can easily reprocess and reconsume data. You can store it forever in an event-based manner with guaranteed ordering and timestamps. And with additional features now, like tiered storage, you can even store data long-term in Kafka, very cost-efficient and scalable, and store even petabytes of data in Kafka. And again, the good thing here is you're very flexible and open. You can combine it with other tools and with legacy and proprietary technologies, and just build it the way you want, no matter if the digital twin is part of Kafka or if it's an external consumer where you build it. One great example of this is the connected car infrastructure of Audi. In their presentation at Kafka Summit, they didn't call it digital twin, right? Which is in the end just another buzzword. But what Audi does here is that they have built a connected car infrastructure for real-time data analysis and swarm intelligence. And also collaborating with partners, because the data is the value. That's the gold, right? And you can also work with third party. For example, when you're driving on the street in real time and correlate with the weather system, with the traffic system, but also with restaurants on the Autobahn, for example. And so there's plenty of use cases. And this is not just about IoT use cases like predictive maintenance, but really also about after sales. So many automotive companies have built these innovative use cases on top of Kafka for real-time data processing at scale globally. The next use case, and I'm pretty open here and honest here, so this is more about research today, what I see, but this is still pretty interesting and coming more and more. It's about additive manufacturing, or also known as 3D printing. And there's different kinds of 3D printing. What we see today already a lot is in the smart factory. So many of the automotive companies, for example, use 3D printing more and more, even in production. On the other side, another kind of use case is prosumer 3D printing, where you have your 3D printer at home and can print things, which is furniture or electronics or toys, or even food and beverage, which sounds really crazy, but that already works, right? And at least in the labs, and this will come to your home. Not for everybody, but for some people it will be cheaper or easier, like in the Star Trek movies where you click a button and then you get your pizza, right? So this is the idea behind that. And with that in mind, so this is more like a distributed manufacturing. So this is a complete game changer for supply chain management, as you can imagine. And therefore, simply the orchestration and the process and the events are flowing differently. And you have to integrate with different systems and again, hybrid. Not just in the factory or in the cloud, but also at the edge in the home of the customer, or maybe in the factory where you want to print it. And typically you stream this information in, like the 3D printing is you're streaming information about what to print, and then you print the physical products in the hardware. And actually, we now see 3 use cases where event streaming comes into play here. As I said before, these topics, if you Google for that, a lot of this is still in research, right? So this is not there in production often, but this is coming more and more. The first example is simply to improve the production process of the 3D printer, because you can continuously stream and process analytics for cost reduction and quality improvement. Like you have seen in a use case before, where you have a production line and where you do continuous streaming analytics, like in the scrap parts early example or image recognition. In the same way, you can improve the process of 3D printing because it's a continuous stream of doing things. And by analyzing this data in real time, you can improve the process of doing the production of 3D printing. Another very interesting use case is security, because as you can imagine, this file in the end, which is the model of the 3D thing which you want to print, that's IP, that's intellectual property. And so if someone else gets the file, he can print the same things, maybe without charging or charging less. So it's a copy, an illegal copy. And so I've seen some research papers where people do not share these files anymore for the printer, but they continuously stream in the information which the printer has to print. So there is no physical file anymore. Instead of the IP is really just streamed and it's never stored somewhere and persisted. So this really then secures that nobody else can use it in this way, or it makes it much harder to do that. And the third use case, of course, is Customer 360. So this is not about the 3D printing itself, but about integrating that into the ecosystem. And for 3D printing, it's the same, or even more important than for other manufacturing processes. Because when the customer, the prosumer is sitting at home and wants to build something new and buy it in a mobile app, and then the 3D printer has to print it, then again, it's a lot of data integration, data processing, all of that in real time, at scale. And that's where Customer 360 comes into play for this, like for many other things. And this is really about the full product lifecycle here. The last use case I want to talk about is augmented reality, another cutting-edge scenario, but in Industry 4.0, it's there in the factories, right? And it's coming more and more. And so this is really about also many different use cases, like virtual prototyping, or about smart assistance of the employees. And also about logistics and warehouse management, where it can simply help if you have, for example, a mobile app or glasses which show you additional information, which helps you doing the right job or doing it more efficient. Augmented reality is there already. There are so many tools and SDKs. No matter if you're coming more from the IT perspective and use 3D engines like Unity or Unreal, which, by the way, today are well known for gaming, but used more and more in manufacturing too. Or, of course, you go more to the traditional vendors from the industrial IoT and OT field, like PTC, for example, here. Or like on the right side, I have shown you a picture which is really great and showing that there are so many vendors with different kind of use cases and solutions which they provide. And there are so many SDKs, so it's a really growing field. So Kafka and event streaming, that's not augmented reality, right? So this is separated, but like so often, it's complementary. And here's one example of that. If you have implemented an augmented reality solution for smart assistants, where you have your mobile app in front of the robot to repair it or to control it, then this is great. But in the end, under the hood, there's a lot of events happening, as you can see on this picture. And so you have to send live metrics from the robots, and you have to receive commands. But on the other side, also the end user has to get this information on a mobile app in real time. And you have to correlate and process data continuously with some applications. And then also the MES system on the top right is interested in this information to send production status and so on. And this is a lot of different technologies here. Like the mobile app typically uses HTTP today. The MES system is more something like Java or Scala, so more JVM based or C#. And on the other side, on the left side, the robots, this is more something like C or C++. And all of them need to orchestrate data. And this is what Kafka shines. So it's not just about Java, but it's about, for example, the Confluent REST proxy for HTTP, or it's about C++, or the data scientist uses Python or maybe C in embedded devices. And then the data correlation is more like stream processing with Kafka Streams or KSQLDB. And this is where Kafka shines, as you see. All of these systems are decoupled and use their own technologies, but leverage Kafka for high availability and high throughput. And with these use cases in mind, and I really want to point out, this was still not all use cases. We see many more of them where Kafka is used. Now, the question is why Confluent for that? And I mean, maybe it's obvious after this talk, but this is exactly what we are doing with our customers. So we are focusing only on Kafka and event streaming. In the meantime, we have over 300 full-time engineers just working on Kafka and the ecosystem. And the ecosystem is products for operations, for monitoring, for helping the developers. But it's also really about the different kinds of deployments, like at the edge in the factory, but also on bare metal in VMs and Kubernetes. And in addition to all that, we also have a fully managed cloud service on all the major cloud providers, which is a serverless deployment model with consumption-based pricing and mission-critical SLAs, so that you only care about your business applications. And then also, obviously, also about the hybrid architectures. And I bet in manufacturing, 70+% of future use cases will be hybrid, because something is somewhere on-premise or at the edge, and something else is in the cloud. And Confluent is the expert here. We are doing the mission-critical deployments everywhere, and we are doing just Kafka and event streaming in its ecosystem. And this is really our expertise, and this is why people come to us and search for our help, both from a tooling perspective, but also with our expertise and global support and so on. And also I want to point out that this is really a journey. So event streaming takes time, you have to learn. You can't start by yourself with open source Kafka and then you build your own first pilot. But you should start the right planning from the beginning, because you should know how your architecture should not just look like today and tomorrow, but also in a year and in 10 years. Because we see really many customers which build global infrastructures with Kafka, with tools like cluster linking and edge deployments with Confluent, and where they connect all their global factories for analytics and real-time processing and building new business and innovative applications. So that's really where we are a good fit to support you with that. So I really hope you like this talk. Please let me know also in the comments, or please connect to me on LinkedIn so that we stay in touch. And you can also connect me on Twitter, of course. And please share your feedback if you like that, if you see any other use cases. I also plan to talk about some of these use cases in much more detail and will write a few more blog posts about that. So let me know if you see any other use cases here and what you're interested in. And let's stay in touch. So thank you for watching and see you next time.